Hi everyone. In this video we are going to explore the instructions of PIC microcontroller. PIC microcontroller, the W register plays a vital role in PIC microcontroller. It is similar to accumulator in 8086 microprocessor and 8051 microcontroller. So W register is nothing but it is a working register. It is represented as a 8-bit register. It starts from D0 to D7. D0, D1, D2 are LSB and D7, D6, D5 are represented as MSB. So in this instructions, we are going to explore the move, add, arithmetic and logical instructions with some examples. Yes, Kunguma Srivartini, can you explain about the move instruction in PIC microcontroller?
So here is the move instruction of PIC microcontroller. Let us take move LW. This MOV represents a move. This L is a literal which holds the constant. This is the work register. In this L is the source register and this is the destination. This is 8-bit data. This 8-bit data contains the range from 0 to 255 for decimal and 0 to FF for hexadecimal. It means for decimal it contains 256 numbers. So let me see one example. Here move LW 25H. Here 25H is the literal value which will store in the W register. Now the value of W register will be 25H. Next add LW instruction. Here add LW instruction means add LWK. K is the constant as we seen before. L is the literal which is the source register and W is the work register. This is the destination. For seeing a small example, let me write move LW 25H, which means the literal value 25H will move to W. Here move in the sense copy. The value of literal 25H will be copied to work register. So the copied work register is stored in destination. Next add LW 34H. So here we already have the value of work register 25H and the literal value 34H. The both literal value and the work register will sum up and give us 59H. So on seeing this example, here the arithmetic logic unit ALU contains two inputs, which is one from work register and another one is 8-bit literal. So here the arithmetic logic unit performs, here we are using ARNO. So addition operation, the answer will be stored in work register. If it contains any carry, it will store in the status register and it shows which type of carry it is. Otherwise it will store in the work register. This is all about move LW.
So till now we are discussing about the literal values presented in the PIC microcontroller. Now we see about the work register and file register location in PIC microcontroller. Can you discuss about the instruction with example?
Yes. One of the move WF register, we can see F stands for an location of file register and W stands for work register. And the CPU is moved to the source of W register and destination is file register. Now we can see one of the example. Put 99H to the location of 0 to 4 in the region of file register. We can form the program. The W work register is stored 99H. Here W work register 99H is copied and the file location is stored 0H. After this, here also the work register is stored 99 and the location file register is stored 1H. After we get 4H.
So wait more.
99H.
So move WF means, so your work register value is 99. That is the 99 value is moved to 0H in the file register location. Now the 0H file register location having the value is 99. Okay. The next instruction is move WF 1H. So now the location is changed to 0 to 1H. Okay. So already the W register having the value is 99. This 99 value is moved to 1 in the file register location. Same as that of move WF2H, move WF3H and move WF4H. Now all the locations of file register 0, 1, 2, 3, 4 having the value of 99H. At the same way the W register also having the value of 99H. So in following this, the next instruction is addition of file register. So can you explain about the addition about the file register?
Now here the add WF file register and D is the destination bit and file register refers to the operand which will be stored here, and D is equal to 0 where the destination result will be stored in work register. When D is equal to 1, the result will be stored in file register. For example, we can take 22H RAM into the location 5. Here L is the literal, it is the source, and W is the work register, where the 22H is copied to the work register and the location is not 5H. Now by adding WF, the work register and file register gives the result as the result will be stored in 5H. So the result will be 44H.
So now we have seen about the arithmetic logic unit instruction. So first instruction is add WF file register comma D. So add W is the value of W register and the value of file register is combined. It is adding. If D is equal to 0, so the value of addition is stored in W register. If the value of D is equal to 0, the result is stored in file register. So the next instruction is, if we add two numbers, the result is maybe can carry. So we use second instruction, add WFC. So the file register comma D is similar for all. So this instruction is for carry. Next add WF. It is a logical instruction. So if W is equal to 1 and F is equal to 1, the result is equal to 1. So if the value of two values, W register and file register, is dissimilar, it also can give the result for odd instruction.
So in subtraction, the instruction sub FWB represents subtract file register value and work register with borrow, and subtract WF represents subtracting work register and file register value, and sub WFB represents subtracting work register and file register value with borrow. Here XOR WF is a logical instruction which where dissimilar values like 0, 1 or 1, 0 the output will be displayed. So if W is 1 and file is 0, the output will be 1, and if W is 1 and file is 0, the output will be 1.
So till now we are discussed about the arithmetic and logical instructions of PIC 18 microcontroller. The first instruction we saw that move LW, that is a literal value instruction. The second one is a move WF, the work register and the destination also file register. And in addition to that, we saw that add WF file register comma D. Based on the destination value, D value, the result will be stored in the work register or file register. And these are all some list of instructions of arithmetic logical instructions present in the PIC 18 microcontroller. Thank you.